let's get started.
Let's get started. So what the heck are web components?
So when you guys saw that word component, you're probably like, well, what is that? Well, I submit that each and every one of you know what a component is because you use them today. You use them in lots of different cases. So the first case is in embedded widgets. So here, if you've got, say, a Google Plus button inside your site, or a like button or something like that.
Or a Twitter button.
This is a third-party bit of code that's running within your site. This is something where you have some trust issues, right? They don't want to allow you to mess with all their stuff or call some of their privileged APIs. So and they also don't want you to style their stuff.
Right.
So they talk a lot about discipline. Like, thou shalt not use anything underneath, style anything underneath my little ID and stuff like that.
Right, and of course, we as users of those widgets go, it's more like an etiquette. Try not to do that stuff, and we'll mess with it the way we want it to make it load fast.
Right, and so in practice, what everyone does, they give up on these iframes for this use case, but that's not really ideal. So another use case is when you're writing your own app, and say you want a tab strip. Well, you shouldn't have to create a tab strip because there are thousands of them that other people have created. You just want to use those. So you just want to grab in a widget or a component that someone else has written and put it inside of your app.
And there are entire libraries written nowadays, and some of them are quite complete, of libraries and widgets and all the different UI elements that you might want to put together. And of course, unfortunately, the problem there is that all of these libraries espouse their own strategy on how to execute the UI widget composition and how these things come together. And so like one of the top Stack Overflow questions would be, how do I use the widget from framework foo in framework bar, right?
And unfortunately, they follow different conventions, so often the answer is you use a lot of duct tape, a lot of scripts, and you sort of jam them together as best you can.
And don't touch those parts.
Yeah, and don't do this, whatever you do.
Right.
So the final one is custom-built widgets.
Are you hungry, Alex? Is that what it is?
So bear with me for a second. You're all familiar with spaghetti code, right? Where you have all these crazy stuff that you got to do really hacky. Well, when you're writing your own apps, you want to have this benefit of encapsulation, right? Because that's how you build more complex things. But it's hard to do in the web platform, so the best you can kind of get is lasagna. You got layers, but they're still kind of messy, right? So even when you're building any kind of app, you're building these custom elements for yourself.
The components is, one use of them. Right?
Yeah. So let's go dive into our example that we'll be walking through today. Right. We're going to build a poll app and show you sort of how we've built this today. So here it is. It's a pretty app. It's got a cool little HTML5 logo. It's got a title, a subtitle, different options. If you aren't familiar with them, you can hover over them to see the information about them. You can select them, and it has a nice selected thing. And you can also see the results and see what other people have voted for. That's right. But let's dive into how this stuff actually works. So I'm going to open up Web Inspector here. And I've got this way zoomed in, which is why it looks so funky.
And if you look at this today, and this is this is a pretty cutting-edge technology even by today's standard, and shout out to David who wrote this code. It's using what you would call the modern principles of web design, and that is, you do see your components right away. You see the poll as one component, which is a backbone view, and then you see the choices view, results view, and all those different things that are put together into a widget hierarchy of some sort, right? Unfortunately, some of the things immediately start jumping out of you and going, well, what's going on here? See those strings there? Your HTML become this just a string, right? It's not a markup anymore. It's just the cottage cheese in your lasagna, right? And so it's at this point, you're starting to go and say, well, I'm not really working in HTML anymore. I'm working in this parallel world that a framework has designed for me. And then what happens is this framework will do the right thing and project the actual HTML or DOM tree into the browser for the user to see. And of course, when the user clicks on something, the backward thing happens. The framework traverses the events back to your tree, to your object hierarchy, and tells you what happened. It's not just a div that was clicked, it's your poll that was selected. Aha, I understand this now. So if you look at this markup right now, you actually see this very clearly, is that markup is not necessarily representative of what the poll is. It's actually a lot of things in addition to just what should be a very simple widget layout, right? You have poll and you have choices, and that's it. What else should be going on here? But there is actually a lot of markup going on. That's because the markup is essentially a projection. And even worse, today, if you load this page, it's just a div in markup. What happens is the framework then blows up this div using the JavaScript, and creates the actual framework out of it. So, and you think this is bad?
Right. Right. So I actually have something that haunts my nightmares, and it will haunt yours too after I show you. So if you open, if you go to say just Gmail, which we all use, know and love, if you switch and look in Web Inspector in here and inspect some random element.
Oh my God.
What is this? What is going on?
Right. This should be a very simple widget tree, right? There's like a list of things, and then there's item. Oh my God, look at this stairway to hell.
Right.
What's going on there, right?
This doesn't make any sense. And so, let's see, let me switch back. So this is in this Bizarro world. And you know, I bet a lot of you watching this were saying, well, that's just how you do it, right? Like, why are you talking about why this is insane? This is just how you make it work.
Right.
But you know what, Dimitri? I submit that everyone in this room who said that is insane, right? This is insane. This is crazy.
We're insane. Yay. All right. But the thing is that it is true. We are doing something to work around the issues in the browser. And we're writing a lot of code. And we're writing frameworks to help us do these bits of code. And then with more code that we write, we have more opportunities for losing test coverage, for example, and not knowing exactly what's happening. And clearly, more code you ship over the wire, the slower your application will go, right? And the development time suffers, of course, unless you stay in the confines of that specific framework, right?
So that's sort of on the low level why this is bad. On a high level, this is bad too, right? If you looked at this DOM, this isn't very semantic at all. Like, I had to look through it. I didn't really understand what those things were doing. The Gmail example is, of course, way on one end of the spectrum. But actually, if we look in our index at Google, we see that the web is getting less and less semantic as we go. There's more divs and spans, and it's harder to understand what's going on.
And more empty divs, like I mentioned before, right? You try to index a page, you go there and you say, oh, there's nothing there. Right. Oh, no, that's actually an NPR app, you know, that loads all kinds of images. You have to run script to understand that it does that, right?
So running script means that you have to make any kind of complicated app, you have to run script. You can't be a web author. You have to be a web developer to make something work today. Okay, so I have one bit of good news. You guys are all insane, but it's not your fault. It's the fault of the platform right now, and that's why you have to do these things.
That's right.
So if you look at this, the way I think of it is the web platform has all these amazing technologies that do all kinds of really cool stuff. But there are a few little potholes, little tiny things that don't work correctly or that are difficult. And you run into them. You're on this information superhighway. Everything's working great. You run into a pothole and you say, oh, I can't handle this, but that's okay. I have script. I have an escape hatch. I will do this in JavaScript. It will be okay. So you go a little tiny bit off-road. That's fine, right? Now you run into another pothole, a deeper pothole off-road, because I mean, you're off-road, right? And it's a pothole that wouldn't have been there had you been on the highway, had you been able to use these normal technologies. But you're off-road. That's okay. You write a little bit more script. You go a little bit more off-road. Nothing's wrong, right? Unfortunately, this leads into a pit of despair, right? Like, the more off-road you go, after a certain point, you're drawing your own cursor. You completely escaped the browser here. So you've started building inside this escape hatch. JavaScript is an escape hatch. If the platform doesn't do what you need, you're now building everything inside that escape hatch, which is crazy. Right. And even if you don't think you are doing it, you think you're doing a very good job of being semantic and all that stuff, well, the framework you're using is doing it for you. They're going completely off-road to do this kind of stuff.
Right, and a lot of these frameworks become so robust. And in order to become robust, in order to offer the experience to you that makes sense, they build entire rendering engines into the browser. So you have this turducken of the thing that actually the rendering engine is just this rendering surface, and then there's another one that's being loaded as a GS file that actually does the stuff for you. And so it's pretty sad.
So yeah, we've been talking all doom and gloom so far, but it's not. We're going to change we're going to turn the page here. And the good news actually is, although we look like normal people, Dimitri and I actually come to you from the future.
Yes, we indeed come from the future, and you must know that there are multiple versions of the future, and there is one, for example, where the alien invasion begins in 15 minutes, and the web platform essentially becomes irrelevant.
But there are also good timelines. The timeline we're from is the one where there's free beer and there's web components, so it's not all bad. So what we want to do is we want to talk to you how web components solves this problem.
So the web components is this new set of technologies that we looked at, we created by looking at these potholes and decided to fill them naturally as things that fit inside of the web platform as a whole. rather than building a whole new crazy thing on the side, which all of us have done before, we decided we're going to fill those holes naturally into something that feels like just part of the web platform, just part of the standard things that you normally do in the browser, not a script and not some crazy invention that is completely brand new. And so what we did is we kind of found out that there's 3 pieces that are missing. And these pieces are ShadowDOM, the custom elements, and the templates.
So let me walk you through what each of these ones means in practice. So again, all these 3 things are what come underneath the umbrella of web components. So the first is ShadowDOM. ShadowDOM is what allows you to encapsulate stuff in the DOM, to hide away all that cruft that you need to make it look correct. Custom elements is what allows you to define your own tags. So when the HTML parser runs into your widget, it can just instantiate it immediately for you. And finally, templates allows you to define HTML DOM snippets very easily. So today you're doing this in long bits of string and script, or you're doing script tags with some templates there.
Right.
This basically just allows you to define it directly in your HTML, have it sort of frozen off to the side so you can swap it in when you need it.
Right. It's kind of neat, as an aside, the developers are really like this massive river, right? There's problems with the web platform, but no matter what, the developers' force will work around them, will flow around those problems.
They will find a way.
Exactly.
So what this is sort of like the low level of what the technologies do, but what does this actually mean in practice?
Well, in practice, what you really are looking for is something that allows you to tell the browser exactly what you mean. This, for example, would be the markup that you actually are trying to communicate to the browser. I have a poll, I have choices, and there's things that are essentially data for my poll, right? Why should there be anything else, right? 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 All right. And so the 3 pieces fit very neatly into this idea. First, ShadowDOM allows you to take the scaffolding and all these weird divs that are really irrelevant to the semantic of the markup and hide them into the ShadowDOM. We'll talk more about that later. And then the custom elements allow you to define new tags, right? The new tags, awesome, expol, right? And specify behavior and assign things on top of them. And then, of course, the templates allow you to stop treating markup as string, which is always nice.
So that's how they help tactically, but they also, of course, are really important on the high level. So if you have this world, if this is all you need to pass down to the browser to have that rich pull experience exist, that means that you don't need this bizarro world off in script. DOM can be your only hierarchy. You don't need to have this parallel bizarro world hierarchy on the side.
You no longer need to build your widget hierarchy as just a object tree somewhere off to the side, the one that projects the DOM as a kabuki theater of some sort.
Right. So DOM can become this lingua franca of the web. It also means that you would have real encapsulation. So you wouldn't have to worry about people coming in and messing with your innards and messing up how your component works because they can't, because they'd be a barrier. So it's not just etiquette or discipline, it's an actual encapsulation barrier. And also, if DOM is the composition mechanism, it already composes really nicely. You can put spans inside of divs and all kinds of stuff.
Right.
If you have that as the framework that you use for composability, that means you have compatible composability. So if you have a widget from framework A and framework B, they can live together harmoniously without having to figure out which calling conventions they have.
Right, and where that one widget begins and where one widget ends, right? That's another important thing. And let's be clear, Web Components is not a set of these widgets. It's just a platform on which the future frameworks, the future where we're from, can build those new frameworks.
Yep, so it's a foundation for this stuff. Okay, so this, actually Web Components, as you may have guessed, makes all this stuff real. So we're going to show you what it looks like in practice.
Good.
So let me switch. This is the demo that we showed. It's built using the best practices of today. And this is what the one with Web Components looks like. Did I mess it up?
Yeah,
looks exactly the same.
Right. So in the future, all applications are going to look exactly the same, right? This is the lesson we're learning. Well, actually, no. What's interesting here is this is actually a functional application, but instead of all these weird spans and divs inside of it, it has a very clear, very concise markup. This markup is exactly the same as the actual DOM structure of of this document, right? So whatever you ship over the wire is exactly the same thing that is represented as DOM. You don't have to create this thing that the frameworks do today, the render and decorate. where you first load the page, and then you go find those things that you want to upgrade and make them into the right stuff. You don't have to do that anymore. All of this happens magically.
Magically, and that's actually a good point. I was going to ask. Clearly, we saw all the extra stuff that's required to make this poll demo work, but it's not here. So what's going on, right?
Well, let's look. And kind of the way you look at this is, in the web platform, we never had this opportunity to build in layering. Layering is like a cool thing. It's also related to the lasagna thing. But all the frameworks, if you look at them today, all of the JavaScript frameworks that are built out today are nothing but attempts to provide a layering in the browser. Because what they want to do is they want to create an environment in which the users of this framework don't have to think about the details. And then the developers of the new widgets, the builders of the components, the ones who work inside of the framework, actually have flexibility and power to provide those new services to the higher level.
And so by having this built into the browser, it means that there's no build step. There's no extra framework you can use. You might be able to build just directly on top of the browser. So what this means with this layering is the users of these components, which is what the vast majority of web developers will be doing, it's super simple. You do an import, you use these tags, it just works. However, if you really want to understand the magic that's going on behind this, you do need to go a little bit behind the scenes. You have to see these more powerful concepts that are a little bit more confusing, that have a lot more to learn about.
We have a choice here. Do you guys want to continue, or should we just stop right here?
Do we want to go behind the scenes?
Behind the scenes, yes!
Okay, so we're going to go behind the scenes. We know you're curious, but if at this point you say, well, what the heck is going on? That's okay. You can just be a user of these components and not have to worry about it. So Dimitri, why don't you take us behind the scenes?
I love the stuff behind the scenes. So first, we're going to talk about ShadowDOM. Believe it or not, ShadowDOM already exists in the browsers, well and alive. And a good example would be a video tag. Let's take a look at this video tag right here embedded into this presentation. Because our presentations are actual HTML as well, right? Isn't that cool?
Okay.
So as you can see, you have really neat video tag right there, right? Video/video, everything looks great. But there's actually more stuff happening. There's a slider there in the timeline and all these things. How do browser developers do this, right? How do they draw those things? Well, they have a couple of choices. One of them is build the whole thing from scratch to build their own heat testing right into this thing. And we're kind of actually lazy, and we didn't do that. What we did instead is we invented a way where we could kind of stash away a DOM tree where we can build those things out of just normal CSS and DOM and operate on them just a normal way. And then we present it to you as if this is a built-in functionality. And this DOM tree, we obviously call ShadowDOM, right? It's in the shadows.
Okay, so how can we see what's going on here?
So one of the interesting things is in the Chrome browser today, you can opt into this experiment, and you can say, well, I want to be able to show ShadowDOM.
Okay.
And so if you reload the inspector, you will see that when you inspect the video, suddenly there is more stuff inside of it.
Ooh, this is
it's a thing called shadow root. That's that hidden DOM that you can't see. Well, let's go inside of it. Oh, there's a div. Oh, interesting. Input type button. That's actually the play button. And then the input type or div style, open that one right there. That will be a type range. That's the slider, right? That's the thing. So what we did is we really, really cheated in a pretty big way, right? We just, instead of building all this stuff in C++, native and all these things, it's just DOM. And in fact, when you play this video and you know how the timeline goes away, that's just a CSS transition, right? It's nothing special.
So what you're saying is that this isn't new. ShadowDOM has existed in some browsers already.
Right.
What's new is just exposing it to web developers.
Right. So what we did next is said, well, wouldn't it be cool if web developers could have the same power? And wouldn't you agree that would be cool? Would that be cool? Yes. All right. So that's what ShadowDOM is about. It's about encapsulation and providing you with the ability to add these extra chunks of tree on the chunk of DOM tree and render them as if they're part of the bigger rendering.
Okay, this is kind of complicated, so let's go through this a little bit more depth.
All right, sounds good. So the next slide here that we see, we have a nice diagram. As you can see, it's peas and radishes, clearly. So the green nodes, the peas, represent the document tree. That's the actual tree that you see when you go into the inspector, and that's the one that is parsed when the browser processes your markup. And the pink stuff is the ShadowDOM tree. So the ShadowDOM allows you to associate a special subtree with every DOM element. And then this subtree, you can build and create divs and all kinds of things inside of it. But then when it's rendered, you actually see the shadow subtree rendered instead of the contents of that node, the element that you associated with.
Okay, so let me go over this one more time. So what we have here on the left, we have these green nodes are just the logical DOM that we're all familiar with. And then off to the right, we have a sort of parallel DOM hierarchy.
That's right.
And so it's just sort of stashed off to the side. But if the shadow DOM is defined, when we render, what we see is as though the pink nodes were underneath the green nodes.
That's
but
right.
Logically, the green ones are still there.
Right. So this is a really, really cool concept right here. It's a render time composition. You don't have to move those nodes around. They're still there. If you walk your first child, next child, that thing, next sibling, there's going to be only the green tree inside of it. But at render time, the ShadowDOM tree will be placed on top and rendered as if it's there.
Well, wait a second. I had real stuff in the green DOM tree. I wanted to show that. It's kind of weird that we just sort of not
this use case is pretty good for a video, but you suddenly lost that other green piece things that were hanging off the element. So what do we do there? We have this really, really cool concept called insertion point. Insertion points are special elements that you can put into your ShadowDOM subtree to designate where the children of the shadow root will poke through. And so as you can see there, I have 2 insertion points. And when it's rendering, again, at render time only, those children will shine through inside of the ShadowDOM tree. So in a way, it allows you to have this way to compose the ShadowDOM subtree around your document node.
So basically, this is the same thing that frameworks are doing today, right? Because you have like your markup, then you call this magic decorate method on it, and that swaps your DOM into the place it needs to be to render.
That's right.
But this leaves it in the same place as before, so you can still interact with it logically like you did before.
The cool thing here, exactly right, is that this is entirely render time. So you don't have to touch the DOM. In fact, the DOM stays exactly the same. What happens is this happens only at render time. So only when this stuff shows up on the page is things appear in the right spot.
Okay, so this is all very abstract. Let's go through it a more concrete example.
Sure. For example, the XChoice element that we had just seen in the markup example here is implemented using ShadowDOM. So you can see there it's a very simple subtree. The ShadowDOM subtree, it has a div in it and has a little mask, which stands for a little icon there. But then you have this really interesting thing called content. Content is a name of the insertion point. It's the HTML element which represents the insertion point. And then you see that it has a select attribute and a value that looks very similar to something. What does it look like? People from the audience?
Is that CSS?
It's
a CSS selector, right? Yeah.
Right, so that's what you use. You use CSS selectors to say which items will show through in my insertion point. And so what we say here is the H3, first of type, which is the first H3 we find as child, is going to show up right here instead of this thing when rendering. And then we have a little aside item for our tooltip. And then we say, everything else, universal selector, goes inside there.
So what we're doing basically is we're using CSS to decide which elements to sort of funnel and teleport where when we render.
That's right.
Okay. So what we're actually kind of doing here too is we're almost defining a declarative API. We say if you provide some H3s, the first one is what we'll use as the actual name for the thing.
Right.
And the later ones we'll just stash on that aside.
So you have this not only mechanism to stash things away into the subtree, you also have a mechanism to now declaratively project some of the items. You don't have to write a bit of script to do this. This is all built in. This is standard stuff. Awesome? Awesome. All right.
Okay.
And so the next thing is we need to take these ShadowDOM subtrees and build them into something useful. And that's where custom elements come in. Custom elements allow you to define a new element. And for that purpose, we have the new HTML element. You know, that's a good name for it, which allows you to specify and say, well, there's my element, XChoice, and inside of it, the template. Remember that template? That's where my ShadowDOM subtree instance is. Every time I create a new XChoice, that will be stamped out and create a new instance of the ShadowDOM subtree. And then you can run script inside of it to do lots of cool things. For example, you can declare an imperative API on this DOM element and say, well, the XChoice method needs extra methods, or XChoice object needs extra methods or properties on it, and you can do this. And also you can define things like a lifecycle hooks, like I want to run some script to register events every time a new instance is created, right? That's useful stuff.
So that's how you define it as a component author. But for component users, all you have to do, you include this link rel equals components and point to the document where this thing is defined. And then you can just use it like any other built-in tag in your page. And also, so you talked about those imperative APIs that you defined here. You defined the was selected on this thing.
Right.
If I go through and grab this element out of the DOM using query selector, say, I can just call that method directly on that object, on the DOM object. The DOM object is the object.
Right. And so there's no faking there, right? There's no need to create separate objects or views or things. Your DOM objects are the actual things that you operate on. When you query the standard DOM APIs, use them, whatever comes back to you is going to be those things that you define.
You don't have to know the conventions of the framework, how we stash things and how DOM and JavaScript are related, because it's just DOM.
And also the link rel, the new rel components, gives you the opportunity to create a packaging mechanism, to build packaging right into the browser. You don't have to have a build script that then compiles all this thing into one gob of code. You don't have to have 5 script tags loaded into your page. One link rel, it can load other link rels if you want, if you have more components that you want to reuse, and that's all it takes. So it's packaging, it's reuse, and also the ability to have one DOM hierarchy instead of multiple tree objects.
So one of the problems that we have today on the web platform is styles sort of naturally go all over the place. So when you're defining a style for your component, it might go and mess up somebody else inadvertently.
That's a very common problem, especially if your object tree is pretty complex. At some point, you really start losing sight of which selector. How many of you guys have committed the cardinal sin of pound important? Okay, be honest here now. And so in ShadowDOM, there is some really cool stuff here. In ShadowDOM, the styles are implicitly or explicitly scoped inside of the ShadowDOM subtree. So even if you put a universal selector inside of the ShadowDOM subtree, it will only apply inside of the ShadowDOM subtree. So it will not go and bleed out into a document. Similarly, styles that you apply in the document will not bleed into your ShadowDOM subtree. So you have a very nice style separation boundary, which really works extremely well for widget case scenarios where you want to have the boundaries defined, and you don't want people to stomp on your styles, and you want to keep some sort of sanity inside of your application.
Okay, so that's sort of behind the scenes. Great, thank you for that, Dimitri. I actually just got a call from a designer. He's watching on the live stream, and he says that we shouldn't have used an accordion, we should have used a tab strip in our demo. That makes a lot more sense.
I actually agree with the designer. Accordions are kind of weird anyway, right? Well, this is a cross between a piano and a harmonica, really. Oh, you're talking about a widget. I'm sorry. Okay, yes. So that's actually really easy. Because we're using just markup, we're just swapping tags. So the idea of swapping out components now becomes just changing your markup, right? So now we have to just include a new component, and then change X accordion to be X tabs. And it's, let's just see what happens, right?
Okay, so you say I have to include the new component, which I actually already did while you were talking. And I needed to just change X- accordion to X- tabs. Is that right?
Yes.
Save that, switch back to the demo, okay? And just refresh, and there we go.
We have tabs. Applause, please. So, no wingsuits, but at least some cool tricks, right? At some point. All right. So this looks really, really awesome, and I'm already kind of enamored with this. I don't know how about you guys, but I really want this poll on my website now.
Oh, on your site?
On my site.
Oh, just so you guys know, I'll show you what Dimitri's website looks like. It's beautiful. It's really special. It's awesome.
Wow.
So no offense, Dimitri. I definitely hear that you want to have this poll on your site. I'm a little bit concerned that you might muck with it a bit. But that's okay. It's okay. I'm going to package this up for you so that you can include it on your site without you worrying about how you're going to set this up. Okay, so first of all, I don't want you to be able to change the text for the choices, because that way you could sort of stack the deck for one of these things.
Well, I could add my own choices, right? CSS3, why not CSS4 or 7?
So what I'm going to do actually is I'm going to create a new element called awesome poll, obviously, for embedding.
It has to be awesome to embed into the awesome side, right?
And then to hide it from people who are embedding it, I'm going to take and put in my ShadowDOM one of those poles. So you can't see it.
Okay.
And then what I'll do is I'll allow myself to define sort of where this configuration is, and I'll then create all the stuff inside the X pole in my own little area.
So have you guys seen Inception? And if you haven't, please leave room now. It's like we have to go one level deeper, right? ShadowDOM inside of the ShadowDOM. You know, seriously cool stuff.
Okay, so what we'll do then you could just put that right in your page, and you'll have a pole right there. Awesome.
Wow, this is beautiful. Well,
what?
Yeah, it kind of looks not like my side, actually. The place my vote clearly doesn't have enough exclamation points.
It's only got one, that's true.
And I don't know. I kind of want to customize it a little.
Okay, so you're right. This is actually technically just as good as an iframe, basically.
Right.
It doesn't really give you any way to customize it. So you have such an interesting vocabulary and way of speaking.
I do.
I don't
I'm
really
a very
want.
colorful person.
I don't know if I want you to have control over everything, but I guess the subtitle and that button will allow you to override. So I'm going to define in my poll. I'm going to allow you to have a declarative API. I'll allow you to define your own aside for that subtitle and your own label text.
That sounds good.
So what we'll do is we'll switch back to your site, and we'll just switch this right here. I will just uncomment. I actually already wrote in here where you had this customization. Save that. Switch back to my demo. Refresh. And vote for CSS3 because it's awesome. Awesome.
Right.
And vote now.
And now I have plenty of exclamation points, right, guys? But
Great.
think about what just happened. Just stop for a second. I have customized the poll without mucking it up because Alex is a developer of this custom component, of this web component, right? The awesome poll only gave me the guardrails to step into these specific areas. And that's all. And the way I do this is by markup. I don't have to go JS and do some weird muckety-muckety JSON stuff. It's just standard HTML.
So cool. So are you happy?
Well, you know, the font kind of looks like this little Vulkan, too clean and creepy. I want something huggable and wonderful. Like, what could be more wonderful than Comic Sans, right? It's just a few curves away. It's from the perfection, right? So what we're going to do is, I want to say that I'm not going to do this unless you let me customize the font.
Right. So I admire design aesthetic. I think it's very unique. But I don't want you to be able to run all over all this stuff and break everything. So I guess what I'm going to allow you to do is change a couple of things in here. But before I do that, I want to walk you through how I'm going to do this. So CSS variables is one new technology. The spec is nearing completion. We actually have it implemented in Chrome behind a flag. CSS variables
Wait. Did you just say CSS variables? Guys, are you getting this? Are you getting the CSS variables?
Yeah, it's kind of cool, right? Because today you have to have, you define pound FF1234, 8,000 places in your CSS. This allows you basically just to define it once. So they're actually really, really powerful. You can do all kinds of cool stuff with Cascade and referencing other variables. We don't need that today, but I really encourage you guys to look more into CSS variables and see all the crazy, amazing stuff you can do. But the cool thing about CSS variables is it allows a very natural place for me to allow you to override what I want. So when I'm writing my poll, I'll use CSS variables very deliberately in places that I want you to be able to hook in and change my stuff.
So these are my styling hooks, right?
Right.
I can come in, but I can't go anywhere else and mess with anything else.
I'm only allowing you to change a few things. So in this case, I'll allow you to change sort of maybe the font and also the colors that we use as the primary color.
Colors are important.
And what you'll do on your sheet is you'll just direct some styles, these variables, at my poll, and then it will magically just work.
Wow.
So let's see
this.
Yeah, let's see this in practice. So I'm going to switch to your CSS, and I'm going to uncomment, which I've already written. So now we're just doing basically what I had.
You made the right choice.
Yes.
This is
Comic Sans, I thought you'd like that.
Okay.
I'm going to switch back to your site, refresh, and there you go. You got Comic Sans.
This is now awesome. I can do this.
Awesome.
But again, take a second to think about this. Now, you as the developer of the widget or a component can give specific instructions to the browser on what to permit the user of the component to do. Isn't that awesome? Isn't that styling APIs? Who wants this? Who wants this?
I want this.
All right.
Cool, so we've walked you through a couple of examples of how to use this stuff and also some of the tactical use cases you can have with this. But I think this is actually a bigger deal than just that. And the way I think of actually, I'm a little bit dramatic, I guess, sometimes, is the Declarative Renaissance. So way long time ago, you just used HTML, you just wrote markup straightforward. And then we started using JavaScript a lot for a lot of stuff, right?
Right.
But now this allows people to return back to writing things very declaratively in most cases.
Right.
There's a lot of stuff that this allows us to happen.
And like one of the most important things that I think is the ability to actually talk via an API or tell the browser, specify, to let the user know these are the things that you can do and no more. And no matter how much you hack on this or do whatever, you can't mess up my stuff. My stuff is safe. I gave you these hooks. That's all you can do. You have CSS variables to do the styling API, and you have the components, the ShadowDOM technology to allow you to have the markup API. And then you, of course, can define the imperative API on custom elements. So the components, web components give you these three things to essentially explicitly define APIs on the components now. Awesome stuff.
Pretty cool. So another one that's really cool is, again, we talked about this before, if your DOM is your composition mechanism, then components from different libraries just work together. This is neat. I'm like, oh, cool, you can get whatever widget you want. But it also means that today we have to spend all this time recreating tab strips and calendar controls and everything in each and every framework.
Right.
And of course, each time you do it, you probably aren't going to get it 100% perfect. You're going to get like 80% of the way there. But if everyone can use any calendar component, then people will start using the better ones. There'll be more of an incentive to build really, really awesome, accessible, beautiful, interactive components. So you'll see a lot better components as well.
Right. And no longer you have to pledge allegiance to a specific framework, that little mini browser that was built inside of your browser. You can say, well, no longer I'm just specifically a backbone man. I can just use markup and mix them around because this is just markup. It's a common medium, just the standard stuff, the standard DOM in your browser. If you look at this, you can clearly see another advantage. For a company or a team of people working on the same web applications, ability to encapsulate offers tremendous advantages, right? Because now you can work on this stuff without worrying about stepping on each other's toes. You can have a clean separation. You can build workflows that actually make sense and not have this crazy schemes of discipline built into this and making sure that your selectors have to start with pound foo and all that thing that you have to do today when you build complex applications.
Cool. So the other case is that, again, most use cases are fully declarative. So these people who don't know script, they don't have a CS degree, they can still be really productive. They can build really cool stuff with these components.
Right. And one of the other things here is because the browser is taking care of loading and understanding the packaging of applications, rendering of the things, it can go much faster. Because the browser ultimately kind of knows more about rendering than any author or any JavaScript ninja could do. Because we have a little more hooks than a standard JavaScript application could.
And the final one, and this one's kind of crazy, so bear with me, is the rise in shared semantics. So today, your semantics might only apply within your site because there's no good way to share them. But if you allow people to define these tags that are useful to web developers, it's very obvious. If we're crawling, for example, across them, we'll see these X poles, and it's very obvious that people find that useful. And so this is a great way for web developers to experiment with new components and things. And after a while, maybe you see that everyone's using tab strips. They're using it in the same basic way. Why don't you just roll that into the spec, roll that into the standard.
Build it into HTML, right?
And build it directly into the browser. Why do you have to define your own? So this is a great place for web developers to help experiment and sort of show us the way as browser developers about what stuff we should be baking directly in.
Right. And if you look at it from another slightly different perspective, is that today there is no path from local semantics, the semantics of your framework, to the global semantics, the public semantics of HTML. Once you build that thing imperatively, there is no existence of the actual tags. There is no path to the tags. Or you can just study those things and look at the patterns and wonder what's the right thing, but there is no path. With the custom tags, you actually start having this path because these are just tags. And now all you have to do is run a really, really large query, which Google can do actually, and figure out which elements are common, right? And then you can know precisely which tags are winning, which tags deserve to become more public, and at some point make it into the HTML spec, for example.
Some really cool stuff. So again, Dimitri and I come from the future, so that's why we can talk about all this amazing stuff. But the good news is actually that the future isn't quite as far away as you might think. We aren't from like years in the future, we're from like a few months in the future, basically. So ShadowDOM and CSS variables are both implemented in Chrome today. They're behind a flag, they aren't released to the web yet, but if you really want to, you can go around and play with them. There are lots of effective polyfills. Polyfills are basically shims that allow you to use functionality before it's directly in the browser. We'll talk about those in a second. And the other thing is this is not a Chrome thing. This is being done in standards. We have a lot of other browser vendors are extremely excited about them. A number of folks from those are in the audience today. We're really working, this is a collaborative effort, standards effort with everybody to build this. So this is something that's, you can actually look forward to using relatively soon.
It's happening, guys. It's coming, seriously.
So what can you guys do that you're all jazzed up about this stuff? Well, you can help the future arrive faster. The one way, there's lots of links and information on this slide. What you should do right now, if you aren't already a member of the Web Components Plus page, is follow us. We have a Google short link right there for you. This is where we post interesting updates about the spec, the implementations, cool examples, blog posts. It's the one place that you can really learn about all the stuff that's going on. And right after this, we're going to post all these links to that Plus page. If you want to, you can read the introduction to web components. You've probably learned that specs are really hard to read, and they often are. But actually, Dimitri's done an amazing job writing an explainer that goes through all these concepts in quite some depth, but in a very readable way.
And I promise there is no Comic Sans on that page, okay? Just if you're scared.
You can also read the CSS variables spec and understand more how that stuff works, all the amazing stuff you can do with it. It's really more powerful than it looks.
And the other thing is that there is actually a lot of really cool discussions happening right now in your present about the web components and working out all the corner cases and working out the kinks of how things should work precisely. I mean, we're in the future, all those things are solved, and we don't have to worry about them, but you guys have to worry about them. Because getting this stuff done just right and making sure this does not suck is really, really important. So please, if you have any gumption for bike shedding or really, really endless discussions with no end, with no particular meaning, please join the standards list and start listening in and start understanding what's going on, what's happening.
But it's also possible to start building with this stuff today. So Dimitri's written a polyfill for web components. All it requires is ShadowDOM, so you would have to turn that on in Chrome to play around with this. That's a really cool thing that actually makes a polyfill for this entire thing, everything we showed you today. That's how we're actually making this run.
You know those self-driving cars? It's like that. It's like a very, very early prototype that you can possibly drive. Bad things may happen, and I'm not, I can't guarantee.
Don't use that one for anything in production today. But actually, there's a really cool library written by Daniel Buchner, who I believe is right there from Mozilla. He's built this really cool library called Xtags. Xtags is basically a polyfill for the custom elements part of what we showed you today. The cool thing about that is this actually works in all major browsers. It uses a number of very clever hacks to do it, but you actually can start building real apps on top of this today if you want with custom elements.
Right, and moreover, Daniel is actually actively at work building a pretty solid toolkit on top of this, the UI widget library that would potentially power some really, really cool applications in the future.
So it's really cool. So check that out once we post the link to the Plus page.
All right.
Great. So that's it. That's all we got for you today. We wanted to share a little bit more about web components, this really exciting thing from the future. Thanks so much for coming out.
And the future bus leaves in 10 minutes, but until then, we can answer your questions if you'd like.
Just come up to one of these microphones that we've got here in the aisles. What about events was the question that we just got from the audience.
Right. The events are actually also handled by the ShadowDOM specifications, and there's really neat things that we do to make sure that the information in the event never escapes outside of the ShadowDOM subtree, but the events are heard. It's called retargeting. And what happens is that if something fires, like for example, if you click a play button in your video element, the event, or the click event, propagates out, but it looks like it came from the video element. Does that make sense? So it's actually a really complex part of these things, and we thought extremely hard to make sure that ShadowDOM feels transparent to the user, and it doesn't look like it's affecting any actual normal operation of the events, but the information from the inside of the ShadowDOM subtree never leaks out on the outside.
Cool. So we got a question at this mic.
So it sounds like a lot of this is helping you with bringing in dependencies and encapsulating code. Have you guys thought much in the spec about dependency management? You know, I mean, obviously a lot of Java developers and a lot of developers in general use Maven for that, so you don't get dependency explosion inside your app.
Right.
There's that encapsulated part, but you know, in a team you want to try and use consistent dependencies across. Has that been addressed in the spec at all?
At this point, there is just early discussions on how this actual linking of the custom elements, the packaging will happen. So this is actually a good time to start talking and start discussing this thing. I mean, we solved it in the future, and you saw it works, but you know, later on.
What about with like media queries, where the widget, the component needs to adapt based on certain breakpoints, and usually those breakpoints are going to be different based on whatever context of the app they're used in.
Right. So one of the interesting things there is that, first of all, we made sure that ShadowDOM actually operates within the confines of CSS. We're not inventing anything normal. So all of the CSS machinery, the way you operate on it, will just work. It just feels, it has the same, it will feel like it's just part of the document. So it will get all of the same information about the size and media queries and things like that.
And if you have a follow-up question, we can answer it also after this as well.
I'm an extension developer and use a script aficionado, and there are lots of templated sites out there that don't use this yet, but that would be great to extend. And are you thinking of how to integrate this into the Chrome extension API so that we can add components where there are none and change them?
ShadowDOM is actually one of the really use cases for extensions, the ones that modify the page on the fly. Because what you can do is you can build a ShadowDOM into an element, and the document doesn't know that it's there. And so yes, it's a very common use case. Yes,
Thank you.
It's coming.
Soon.
I'm a Google Maps developer, but was thinking, could you embed the map API into the ShadowDOM so you could build a custom tag, for example, a store locator, and give that to a customer and say, hey, do this, and
so yes, you could actually, that's a phenomenal use case, is doing exactly that. In fact, one of the components in Xtags today
you should talk to this guy. He's already got one.
Yeah. So that's an awesome use case for it. Yep.
Come on.
Anything else?
Bring it on.
What about SEO? Like, there's potential information like the side tag that would be less important. Would Googlebot pick that up because it's not potentially rendered on the page?
So we don't work on the search team, so we don't know the answer to that question. But we can imagine there's going to be some interesting changes in the way that people construct their sites.
It doesn't have to be an aside tag. It can be an H1 or bold if you want it to. It's up to you to define it as the author of the API.
Cool. And if there are any other questions, Dimitri and I will be hanging around for a few minutes afterwards if you want to ask us any other questions. Thanks so much. Oh.
Yay.
I'm sorry?